use uh, horizontal force 40 kilonewton as in my notebook. So in your, I think in your notes, yeah, it is 20, yeah, but now I make it 40 kilonewton, yeah. Okay, so I have shown you this one, yeah, to first check the stability and determinacy, yeah, and in this question it is found that the thrust is determinate externally and internally. So when it is determinate, then we can proceed with the solution. Otherwise we cannot proceed because the structure is whether unstable, collapse, or it is stable but indeterminate. When it is indeterminate, we cannot use the method of force resolution. We have to use the advanced method, yeah, which we will learn next year, yeah, or in final year, in finite element. Okay. So this is example. Yeah, yeah, this is the reaction. This is the reaction. RH is equal to 107.5 and RA 92.5 and HA equal to 40. Okay, now this is first resolution. So it is quite tedious, quite tedious, and also, yeah, maybe, yeah, you tend to make, yeah, an error, yeah, but you have to, yeah, similar to join, join method, we have to prove or to check the error at the last point. You will see later. Okay. But this slide, is quite difficult for you, yeah, to know, to understand which one first, yeah, step by step. So I use another slide here. We start from zero, yeah, we start from empty. Yeah, this is the just, yeah, the reaction and also the reaction horizontal and vertical. So from which member we start? Yeah, similar to joint method. We start with the member, sorry, we start with join with only two members. Yeah, we start with the join with only two members. Okay, so I have gone through all these members to join, and this is, yeah, what I record, yeah, the sequence, yeah, the step by step, yeah, start with RA, ABX, ABY, ABX, AC, and so on, yeah. But this is not important. Now we start now. Okay, we start with RA, okay, and then we start with AB and AC, okay. AB, which one? AB Y direction or AB X direction? Okay. For AB X direction, we can use 40, but we have two members. We have two members with, yeah, two members with two horizontal component, AB and AC. So we cannot use, or we cannot start with AC. Sorry, we cannot start with horizontal because there are two horizontal component. I repeat, there are two horizontal component for AB, one for AB, one for AC, and we have 40 here. So by only one equation, horizontal equation, we cannot solve the problem. So that we go to vertical. For the vertical component, yeah, only AB, yeah, got one vertical component. AC, no vertical component. So that we can start with AB. Okay. What is 92.5? 92.5 is reaction. Yeah, sorry. Yeah, it is not shown here, reaction. Okay. When it is 92.5, what is the horizontal component? We know that the resolution, the resultant of these two rectangular component should collinear with this member. So when it to be collinear with this member, when it is 92.5, So this one should be 92.5 multiplied by 2 divided by 1.5 equal to 123.3. So why it is 2.2 or 1.5? Because this one is 2, this one is 1.5. Yeah, and as I said last day, we have to familiar with sine and cosine or with the component x and y. Okay. So we must do it carefully, yeah, and also quickly. Yes. Okay. And then this member, yeah, this member should be equilibrium. For this member to be equilibrium, yeah, so we must have another couple of member, yeah, another set of force, yeah, which will make this member to be in equilibrium. Yeah, that is, this is 123, this is 92.5. No calculation. Yeah, just take this value. Now this member is in equilibrium. Now once you know this is 123 horizontal, then we can go to AC. We can go to AC. Yeah. Okay. For AC, yeah, for this joint A to be equilibrium, yeah, therefore AC should be 40 plus 123.3 equal to 163.3. Okay, and it is tension. Yeah, it is tension. Okay. Now, when we know AC, then yeah, we can calculate CE. Yeah, then we can calculate CE. What about CB? Yeah, CB is zero force member. Because why? Yeah, because C is a three-member joint where two of the members are collinear and there is no external force. Therefore, CB is equal to 0. When it is collinear and this is 0, therefore, CE is also equal to 163. Okay. Okay, we can go to CE, yeah, but we cannot go to E because there are too many members. So what we can do now is we go to B. We go to B because at B we have what? Yeah, known already, yeah. We have two members. Okay. Where you have two members and one of the member BD is horizontal. If you have two members, yeah, but both members are inclined, it is quite difficult. Where you have to write the simultaneous equation. Okay, but if you have only one member slanting and one member, yeah, horizontal or vertical, then we can do it on the spot. Okay, so that's, yeah, how, yeah, you can choose which the best point, yeah, you have to go. Okay, now we go to what? We go to B. We go to B. Okay, for joint B, yeah, for joint B, you have what vertical component? You have 50. This one 0. BD no vertical component. So yeah, simply we can calculate what is the vertical component of BE. 92.5 minus 50 equal to 42.5. 50 is here. And then, yeah, the horizontal, yeah, by ratio, yeah, the horizontal is equal to 42.5. 2 divided by 1.5, 56.7. 2 divided 1.5 is equal tangent of this angle. Tangent. Okay. So now when you know this force, Then what else? Yeah. What left is only BD. So what is BD? BD is equal to, yes, sorry, this one for rigid, yeah, rigid body equilibrium. Now you can calculate BD. BD is equal to what? 123.3 plus 40 plus 56.7. Then it is BD. Yeah, it is BD to counter action or to counteract or to counterclockwise the horizontal component. Okay, and BD is in what? Compression. Okay, and now once you know BD, very easy, you can also know the force in DE at DF 220. What's about DE? DE, because this is 20, this is 20, so DE should be equal to 100. Should be equal to 100. Yeah. When there are three member, yeah, meeting at a joint, yeah, and two member has the same force, then yeah, the other two members should be equal, which is equal to 100. Yeah, and so on. Yeah, I think I don't have to uh, show you one by one. Yeah, I just show you the step now. 100, and then yeah, go to EF, and then the horizontal component of EF. Then you can go to EG. Then you go to GH. Then yeah, you go to GF equal to 0. Yeah, this is same condition as BC. And then where you go now? Okay, you can also start from H. You can start from H here, yeah, and then okay, then the last part of this calculation is to prove that your calculation are correct. Yeah, you must prove that point F is in equilibrium. Okay, point F is in equilibrium. Now, is it equilibrium? 20 minus 76.7 minus 143.5 is equal to 0. Once 107 minus 50 minus 57 equal to 0. So that means our calculation is correct. If it is not equal to 0 here, then you have to repeat or you have to check your calculation. Okay, I hope you understand. Yeah. I don't know whether you have this figure or not. Yeah. If you respond to me that you don't have this figure or you don't have this calculation, yeah, I can screenshot and yeah, WhatsApp to you. Do you have this figure? No. No, eh? No response? Are you
No.
here now? Yeah?
No figure.
No, eh? You don't have with you. Yeah? Meaning you don't have the solution, eh? Okay, I'll take screenshot, yeah, after the lecture, and I'll yeah, WhatsApp to all of you. Okay? Okay. And about zero force member, I have given to you one example, yeah, last day. And today I give you another example. Yeah, another example here. Okay. So this one, why it is zero? Because yeah, three members meeting at a joint, yeah, at a joint, where two members are collinear and there is no external force, so that the force in this member is zero. Okay, yeah, is zero. Now you go here. this member is also zero because it is connected to two member collinear, no external force, so this one is zero. When it is zero, when it is zero, therefore it is zero. It is quite small. When it is zero, then you have only one member left here, only one. Similar to here, this one. This one. Two member meeting or three member meeting at a joint where two members are collinear and there is no external force. Therefore, the third member is equal to zero force member. Okay, and look at this. This side. There is no external force. You start here 0, 0. When it is 0, this one is 0. When it is 0 and it is 0, therefore it is 0. Okay. And this is the what? This is the result of this zero force member checking. Then only 1, 2, 3, 4, 5, 6, 7. Only 7 member. Okay. In this case, we have loading, but here we have loading here. So what the difference? 0, 0, 0, 0, 0, similar to this one. And for this one, 0 here, but this one is not 0 because you have external load here, not 0. So when it is not 0, that means it is not 0 and it is also not 0. So at the end, this is the member. Member which we have to calculate the force. Okay, that's zero force member. I have shown you this one. Okay. I have also shown you this one. Zero member. This one zero member. This one zero member. What about this one? Zero member. Zero force member. Zero force member. When it is zero force member, that means this one also zero force member. When this one is zero force member, this one also zero force member. When this one zero force member, this one's zero force member also. When this one zero force member, that means this one is equal to 10. 10. And now when we have force here, that means it is not zero force member. So sorry, there is no indication here, no marks here. But this is the how to check the zero force member. Okay. And what about this one? Zero force member, zero force member, zero force member, zero force member. Okay. That's just example. Okay. There are many more examples you can check from the textbook. Okay. Now, the next topic. We have about 1.5 hours for this topic on deformation of plane thrust. In this case, is statically determinate plane thrust. We are not discussing about the indeterminate thrust. Only determinate thrust. If you are, if it is about indeterminate thrust, then we have to use another method. Visual work method or computerized software. In this case, we use visual work method, but not visual work to find the force. The force in a member, for indeterminate thrust, we can use visual work method. Okay, but it is not covered in this topic. When a structure is loaded, its stress elements deform. When a load is imposed to load, then it will be stressed and it will deform. Which it will extend or elongate if it is in tension, or it will compress or shorten when it is in compression. This is the basic in your first topic, first topic, I think topic 1. And at this deformation occur, the structure changes shape and points on the structure. Yeah, changes shape. It deflect. The whole structure is deflect. Yeah. Because why? Because every member, yeah, every member deform, whether it shorten or elongation. Okay. And we can use the method of visual work to determine the displacement of a truss joint when the truss is subjected to an external load, temperature, or fabrication error. So we will have 3 examples in the next slide. Due to external loading, due to temperature, and also due to fabrication error. Yeah, sorry, fabrication. We don't have example on fabrication error. Okay. Before we go to visual work, yeah, I think this is relevant. Yeah, we learn this one in static. Sorry, in mechanic, engineering mechanic. Yeah, static kinematic. About energy. When a bar is loaded axially, it will deform and store strain energy U. Yeah? When a bar is elongated or loaded axially, it will deform DL. Yeah? And yeah, this will result in work and stored in this member as energy. Yeah? As energy. Yeah? You imagine spring, yeah? Spring. Yeah? When you compress spring or you pull pull out spring, yeah? It will store energy, and when you release, yeah, it will what? It will bouncing, yeah, because of the energy stored in the spring. Okay. If the bar behaves elastically, yeah, because every material is following Hooke's law, our ideal condition or idealization in structure analysis is that every material, all material are following Hooke's law. That means it is elastic. Whether it is steel or whether it is concrete or whether it is whatever metal, yeah, it follows elastic Hooke's law. The magnitude of the strain energy used stored in a bar by a force that increases linearly from 0 to final value, dl, yeah, where dl is equal to PL over AE. This is as what we have done in first topic. Yeah, elongation is equal to PL over AE. So dl multiplied by U is equal to energy. What energy? Yeah, just as information. Just as information. Okay. What is visual work method? The principle of visual work method, you can find the definition of visual method in the textbook. But the principle here is that work of external load equal to work of internal load. This is similar to conservation of energy. Okay, when you use your energy, yeah, to impose load or impose force on certain thing, the whole of your energy will be stored in material. This is conservation of energy, similar to work. Work of external load equal to work of internal load. What is external load? External work. When a force F undergoes a displacement dx in the same direction as the force, and internal work when the internal displacement delta occur at each point of internal load U. Okay. For example, this point deflect dx. So the force F multiplied by dx is equal to the energy or the force in each member multiplied by elongation of deformation of each member. Okay. This is the member. Not all. This is not all. It's supposed to be all member. So all member store energy or all member store work. And when you sum up all the work in this member or all the energy in this member, the sum or the total is equal to the work done on this structure here. This is analogy. For example, this one, okay, this is a human, yeah, a man lifting load, maybe, for example, 0.5 meter, yeah, 0.5 meter, this one 10 kilogram. What is the load? What's the work? Work is equal to load multiplied by the distance, yeah, the height you lift up, yeah, the load. And the work done on this box weight actually is not possible if your body, the whole of your body, cannot store energy or cannot supply the energy. For example, here, yeah, you have energy here, yeah, energy, yeah, in terms of what? Of bone, the strength of bone, the strength of muscle, yeah, and then you also have energy here, until here, you have energy. So the work done by all this part of your body is equal to the external load on this box. Similar to this one, yeah, this is weight here, yeah, weight. So you need work, yeah, to lift this weight, yeah, up to, for example, 10 meter, and this work is the result of all the work done by all the member here, yeah, down to the ground. So each member will share the load, yeah, the work, yeah, to, and the total is equal to the external work. External work is equal to weight of the load multiplied by the distance of lifting. Okay. So now, yeah, go back to the theory. Consider to determine vertical deformation at joint C. Yeah, for example, this is the simple truss. Yeah, you have one node here, one node here, one node here. Yeah, and now, yeah, you are required to determine vertical deformation at joint C. Yeah, can be E, G, or anywhere, but in this case, joint C. Okay. Due to external load, the truss will deform, producing displacement delta at point C. Delta at point C. Okay. So now, the first step is that, yeah, the first step is that calculate the member forces for actual structure. Yeah, this one actual structure, and this one the actual load, real load here. Yeah, load and reaction. Okay, for example here, this is the load in each member. Force in each member. Yeah, PAB, PBD, PDF, and so on. Okay, now the second stage, eliminate all external load and assign one unit load vertical at point C. This structure is known as virtual structure. The load should be in the same direction as the specified displacement, yeah, for example, horizontal or vertical. So in this case, if the question is to find the vertical displacement at point C, therefore, we apply one unit load vertically at point C. If the question is to find what is the horizontal horizontal displacement at point C, then we apply horizontal at point C. Okay, now, when a unit force acting on a truss joint C and resulted a displacement of delta, the external work is equal to 1 multiplied by delta. This is external load. What is delta? Delta actually is the actual displacement due to real load. Yeah, delta is the actual displacement due to the real load. in this case, the same delta, yeah, the same delta, yeah, but now, yeah, all the external load, yeah, we replace with one unit load here, so that, yeah, when we multiply one, multiply delta, we got external work. We call it external work. So this external work, will be shared by internal load in each member. What is internal load in each member? Internal force. The internal force in each member is equal to the force in each member multiplied by the deformation of each member. What is the deformation of each member? Yeah, we can calculate the deformation. If we know the force, then we can calculate what is the deformation. Yeah, because every member of this structure actually they deform. If there is no deformation at all, no deformation, there will be no overall deflection. Unless, yeah, all member deform, then only we have deflection. Okay. So due to unit load, this is the internal force. This is the internal force. Okay. And then the external work W is equal to 1 multiplied by delta. Here, the external load is 1 multiplied by delta. If P is the member force due to external load and U is the member force due to unit load, okay, P due to external load, yeah, and U due to one unit load, yeah, and this member will produce certain deformation which can be calculated given as work of external load equal to work of internal load. Okay, and work of internal load, yeah, is equal to U multiplied by delta, where delta is deformation of each load. Each member. Delta equal to PL over AE. Actual deformation, yeah. Delta is actual deformation. U is actual deflection. Okay, so this is the formula. Maybe, yeah, maybe it takes time for you to understand the principle of mutual method, yeah. But it is, I think, yeah, easy for you, yeah, to, yeah, understand and to memorize this formula. Yeah, work of internal force, work of internal load equal to work of internal load, or external load equal to internal work. Okay. So the matter now is for us to understand and to remember what is P, what is delta, what is U, what is delta. Delta is the one that we are going to calculate. Delta. P is the force in each member. Remember, P is the force in each member. U is the force in each member due to one unit load. Delta is the extension or deformation of each member. Yeah, of each member due to P. Yeah, due to P. Okay. So, okay. So through combination, the amount of internal work is given by K. Yeah. And according to external work method, yeah, according to virtual work method, or energy work method, yeah, the same, energy work method, external load equal to internal load. So 1 multiplied by delta equal to U PL over AE, where PL over AE, yeah, is the deformation of each member. Okay. We go to the example now. Okay. So some additional information here. If the resultant of some, we go to table, because if we explain without table or without example, it's quite difficult. Wait, we go to the table and then we see, which one is positive, which one is negative, which one is in compression, which one is downward deflection or upward deflection. Okay, example. Determine the vertical displacement of joint C of the steel truss shown in figure. The cross-sectional area of each member is A equal to 300 and E equal to 200. Why you need E? Because it will calculate the deformation of each member, and also A, because the deformation is equal to PL over AE. We don't need I, moment of inertia, because this is axial deformation. What we are doing now is axial deformation only. There is no bending, because it is truss. For the truss, the member is in axial force and deformation. No bending moment, no bending deflection. Okay, so we just need what are A value and E value. Joint C, which one joint C? This one joint C. Okay, now. Okay, in this case, if you want to check the determinacy and stability, okay, but we just skip it, skip and go, straight to the solution. First step is to calculate the member force due to virtual force. Sorry. Yes, virtual force. Virtual force is 1 unit load here. 1 unit load at the point, in question. The point here is C. So apply C. Apply at C. And remove all the other external load. 20 remove. Okay. And now, calculate the member forces. One, and then calculate the reaction here. This one. When the question is about the displacement or deformation, actually you have to familiar with the force calculation. Because if the question is about deflection, then in exam, the most part of the marks will be for deflection. Maybe 80% of the marks will be in the calculation of deflection. Only 20% on the member forces. But if your member forces are not correct, then you'll get the deformation value not correct. Okay, that means you lost 80% of the marks. So therefore, to determine this force is very, very important. Very, very important. Okay, actually I have another method. You have the joint method, we have section method, we have resolution method, but this method, I have another number 4 method, is also resolution, and we call it resultant. I can give you another calculation, yeah, using this method. Yeah, we don't have to show the component here or the resolution of force. Yeah, we can set away calculate what is this value. Okay, what is this value? Okay, I can show you. I can sorry, I can share with you. Yeah, after the lecture. Okay, so this is the force, and then this is the internal force or the member force due to actual force. Actually, should be this one first, and then yeah, this one. Yeah, but whatever. Yeah, at the end, yeah, we'll get this the same answer. Okay. Now you have U. This one is U. You have P, or in this case N. Now because yeah, we use summation of each member. That means if there are 10 members, it is not easy, yeah, for you to write, yeah, in sentence form. Then yeah, it is easier for us to write in tabular form here. So what is the formula? This is the formula. Again, yeah, again and again. This is the formula. So this is the table. U P UPL. Yeah, UPL. Okay. Yeah. Then yeah. What's about AE? AE. What is AE here? Okay. A and E. A is 300, and it is similar to all the member. E equal to 200, and it is also similar to all the member. When AE is constant throughout the structural member, then we don't have to calculate A and E in this table because it is consistent. It is constant. So AE is here. Yeah, 300 by 200. This one is AE. I repeat again. Since in this question AE is constant for all the member, then we don't have to put column of AE here. But if AE is not consistent, then we need, yeah, to put in the column here, yeah, and then calculate, yeah, for each column. Okay, so this is the answer. Yeah, 1 multiplied by delta equal to, yeah, this one is external load, and this one is internal work. Yeah, external work, internal work, UDL. And what is DL? DL is the deformation, elongation, or contraction, and DL is equal to PL over AE. Yeah, PL over AE. And yeah, the result here is that delta at point C vertically, V vertically, is equal to 6.16 millimeter. Is it millimeter or meter? So this is also quite critical, to make sure, yeah, at all stage of calculation, yeah, the unit that you are using, yeah, to be consistent. Yeah? If you use millimeter, then you have to, yeah, be consistent, yeah, using millimeter in all calculation, and also Newton or kilonewton. Yeah, Newton or kilonewton. So it is to be consistent. But what is U? Yeah? U is 1 unit load. What is the unit of U? No unit. Yeah, unit load. Just unit load. Okay. Okay. Uh, it is already nearly 1 hour. Yeah. Any questions so far? I don't know whether you can. Yeah. Because some of
Doctor,
you have no audio, or some of you maybe you have no video, no camera. Uh,
Doctor,
any question that we can maybe, I don't know whether it's convenience or not, to ask question through this online.
Doctor.
Mm. Uh, Sorry, I adjust the volume. Okay. I'm not very familiar with the online how to adjust the volume. Okay. No, sorry. Mm, okay. Okay. What the question?
Doctor, how did you calculate the virtual force?
Virtual force. Okay. Virtual force, U. Okay. Here. Is it this slide,
Yes, Doctor.
Yeah.
Yes.
This is 1 unit load, 1 unit load. Yeah. Uh, this is similar to this one. Yeah. Calculate the reaction first here. Yeah. There is no horizontal reaction because there is no horizontal force. Yeah. By ratio, yeah, 1, 2, 3. So by ratio it is 0.667 or 2/3, and this one is 1/3. Yeah. Actually, yeah. In normally I just put it 2/3, this one 1/3. Okay. So here, this is the one that, yeah, I told you just now. Yeah. It is based on joint method or can be resolution. This one. Yeah. But as I said just now, I have another method. Yeah. Method number 4, that I can straight away calculate this value. Yeah. Calculate this value. Because it is quite difficult to write here. For example, 0.943. What is this? This one is equal to 0.667, okay, multiplied by, what is the distance? Multiplied by 3. So multiply by this one 3, this one 3. So what is this? Yeah, 3 square root 2. Okay, this one is equal to 0.667 multiplied by 3 square root 2, okay, equal to 0.943, or 0.667 multiplied by 1.412, or 0.667 divided by tangent 45 degree, because this one is 45 degree. Okay, 0.667 is equal to 0.943, yeah, 0.943 multiplied by cos 45 degree, or, yeah, or multiplied by 0.707. Okay, it is quite difficult for you to imagine, yeah, but I'll give to you, yeah, this method, this method together with the resolution method after the class today. But anyway, to answer your question, basically, we have learned this method by using join method or by using resolution method. What about section method? Sectional method, Sectional method is not suitable here because we have to know the force in each member. Sectional method, if you want to know the force at this in these three member, then it is okay. But if you want to know the force in all member, then you have to know join method or resolution method. Okay, so in summary, this is just similar. The one that we need to understand is this formula here, and how this formula is represented in this table. Okay, and again, I repeat again, in this question, A and E is consistent or constant. A and E is constant for all members. If A is not constant and E is not constant, then you have to insert another two column here. Column for A, column for E. Similar to L. L is not consistent, not constant. Therefore you need a column here. Okay. I hope I answered the question. Now we have another displacement. Another type of displacement. Now this displacement is due to temperature and also due to lack of heat. Okay. In some cases, truss members may change their length due to temperature. Truss member here. Truss member means not the structure. For the structure, we call it deflection or deformation. And for truss member, it is elongation or contraction or shorten. Truss member. The change in length of a member, of each member, is delta L equal to alpha delta TL. This one is in topic 2, in the subject. You remember, alpha is equal to coefficient of thermal expansion of member, and delta T is the change in temperature of members, not the temperature, the change in temperature. If there is no change in temperature, there will be no deformation, no change in length. No change in length. Okay. And L is the length here. So this is the original length. And then when it is heated or increase the temperature, then it will what? Elongate. Extend. There is no contraction or there is no shortening due to temperature. When temperature increase, it will extend. When temperature decrease, it will contract or shorten. Okay. And this also the basic formula that we have to remember. You have to remember throughout your life. Delta L equal to alpha delta TL. Okay. And about thermal force, this is additional slide about thermal force. To make it to make us aware of the cases when the thermal force is zero or cases when the thermal force is not equal to zero. For example, here, this one bar, bar, okay. This is rigid joint or rigid support here. When this bar is heated, increase in temperature, or applied thermal loading, then it will extend. Delta L. But what is the thermal force here? Equal to zero because it's free. It is free to extend. So even if you apply here, you impose temperature increase 100 degrees Celsius, what is the force? Zero. Thermal force is zero. The thermal force will exist only if there is another rigid support, constraint, constraint here. So when it is constrained, this deformation or this elongation, is what? Is stopped by this rigid joint, and then it will be in compression. It will be in compression. And thermal force equal to alpha delta T A equal to E. How to get this formula? You have to go to this one here. Then you got this formula. Thermal force equal to alpha delta T thermal increase A E. So that means when we are working with thermal force, we need to know A and E. A and E. When there is no thermal force, when there is no thermal, in some cases we don't have to know A and E. Okay. That one thermal force. Another element of force or another cause of force, which will induce in the member is fabrication error or lack of fit. This is the explanation here. Errors in fabricating the length of members of a truss may occur. Also, in some cases, truss member must be made slightly longer or shorter in order to give the truss a chamber or camber. In the case of such lack of fit, the displacement of a truss joint from its expected position can be determined from direct application. This is camber. In some cases, when the truss is long span, when the truss long span or bridge or roof truss which long span, we make it camber or we make it what? About like bow, slightly deflected upwards. Because why? Because to cater for vertical downward deflection due to loading. If there is no camber, due to loading, it will deflect. So it is not good. When it deflect, then it will make ceiling and other services broken. Therefore, before you install or before you fabricate, before you mount it on the support, we make it camber. So how to make it into this camber form? So we have to adjust, the length of each member. So maybe, the length of each member maybe 1 meter in your design or in your calculation, but you have to make it slightly longer, because it is to cater for the loading here, to make it deflect into horizontal position, which we need to have that kind of structure. We must have horizontal, because if it is not horizontal, then what happened to ceiling or to services conduit will broken. So therefore we make it camber. Okay. So the displacement of a truss joint from its expected position can be determined from direct application. 1 multiply delta U delta L. What is this? This one is deformation of each member. Deformation of each member multiplied by U is the force. Is the force in a member due to the unit load. Okay. What the difference here? Okay. Here, this is the force, and this one is deflection. This one is actually delta L. But due to temperature, delta L equal to alpha delta TL. Due to lack of heat, delta L equal to what? PL over AE. Okay. Okay. This is what's by lack of heat. What's mean by lack of heat? Just take it for a typical example. In construction, or in installation of structure, sometimes there is lack of fit due to error here, where you have to force, you have to force this member to fit into the bolt. In your drawing, in your paper, in your drawing board, you can do any kind of fabrication or alignment, but in actual, it is not as that easy actually. Sometimes you have make hole here, hole here, because this one is actually on the ground. You fabricate all this cutting, all this fabrication, all this bolt hole on the ground, and then you install on site. During the installation, there might be the problem of error or lack of fit, where you have to force this member into the position. And in the process of forcing this member into the position, then this member will be subjected to additional force, where this additional force will subsequently impose causing deflection. Okay. This is lack of fit. Additional slide. So when the member is longer than the distance between joint, then you have to force. You have to force or to force back this member. To force or to compress. Compress, force, or push. So when it is pushed or compressed, then it will be in compression. But in here, yeah, the member is slightly shorter than it's supposed to be. Yeah. So in this case, you have to pull, to force pulling this member, yeah, to fit to the joint. Then it will be in tension. That's about lack of fit. Yeah. But it's no example here. This example, this example is only for thermal, thermal. Yeah. There's no example on lack of fit. Okay. Determine the vertical displacement of joint C of the steel truss, okay, due to radiant heating from the wall. Member AD is subjected to an increase in temperature of delta T equal to 60. Take alpha equal to 1.08, yeah, multiply by 10 to the power of minus 5 per degree Celsius. I think, yeah, you know already the unit of alpha, the thermal expansion coefficient, the unit is per degree Celsius, and E equal to 200. The cross-sectional area of each member is indicated in the figure. So in this case, the cross-section is not uniform. So when the cross-section is not uniform, then you have to, yeah, you have to insert it into the table. Yeah, but E is uniform. Yeah, E is uniform. Yeah, okay. What else? Okay, 60 AD. Yeah, this one. So what happened? Yeah, what happened? Okay. Okay. First step, calculate the member force due to virtual force imposed on point C. Actually, you can choose either one. Whether you can start with unit load, or also you can start with actual force. Okay. So the point in question is point C. Yeah. The point to be calculated for the deflection is point C. Therefore, yeah, the unit load or the virtual force is to be imposed on point C, vertical or horizontal. Look at the question. The question is vertical displacement. So then, yeah, we put here vertical force 1 unit load at point C. Okay. So this is simple. This is very simple thrust. Yeah. What is the force in the member? Yeah. Okay. In this case, yeah, we have to be clever, quick decision. Member CB and member AB, AB and BC is zero force member. Why it is zero force member? Because this member BC and BA, yeah, meet at a joint where there is no external force. Two member meet at the joint where there is no external force. The force in each member is equal to 0. So now what left here is only 3 members. Yeah, only 3 members. Okay. Okay. So here, one So what is this? This one is equal to 1 multiplied by 1 multiplied by this boundary, yeah, divided by, multiplied by this boundary divided by this boundary. Equal to 1 multiplied by what? 2.4, 3.6. This one is 3.6 divided by 2.4. You got 1.25. Also for this question, I'll give you the step by step, yeah, how to get 1.25. It is important because, yeah, because when you go to the next year, where you have to design, yeah, structure, okay, the part of force analysis you should be very quickly. So you cannot use joint method, you cannot use also cutting or section method, yeah. Resolution, okay, yeah, but the best thing if you can use this method where you can, yeah, straight away calculating what is the force in each member, yeah. Okay, so this is 1.25, and when you got this 1.25, then you got here 0.75. When it is 0.75, then automatically this one should be simply 0.75. Okay. When this is 1, so this one should be equal to 1. And so on. Similarly, this one. What is 500? Yeah. This one is 400. So therefore, this one is 400. There is no zero member here. Yeah. There's no zero member here because why? Because AB and CB meeting at a joint, but this joint, yeah, this joint got external load. Therefore, yeah, therefore, this member is not zero member. Maybe zero, yeah, maybe not, but it's not automatically zero member. Okay. Okay. Yeah, another 40 minutes. Yeah. Okay. So I think I don't have to go step by step here. Yeah, just now, yeah, 500. What is 500? 500 is calculated. Yeah, 400 multiplied by, yeah, multiplied by 3.6. This one 3.6 divided by 2.4. You have 500. This one is zero because, yeah, because this force, yeah, this force is collinear, yeah, meaning that this member and this force collinear, therefore the third member will be zero member. So collinear means, yeah, it does not necessarily two member, but also one member and one force. It is inline, collinear. So this one should be zero. Whether this one is 30 degree, or whether this one is 90 degree, or, yeah, 60 degree or 30 degree, this one will be zero. Okay. Now, okay. Using this formula, this one is external load, external work. This one is internal. This one also is internal. What is this? Yeah, this one is internal work due to deformation of each member under the actual load. This one is internal work due to thermal force in each member. So that means for each member you will have two components of internal work. One is due to thermal force, another one is due to the member force. Okay. So now in your slide, I noticed that you use this formula. Okay, this formula is correct. But generally, we can use this table. We can use this table, similar to the previous example. Because by using this table, it is you can minimize the tendency to make error. Compared to this one. Actually, if you are not good in doing calculation, it is quite difficult for us to avoid mistake. So better to do calculate in this table. Okay, how many member? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. L, A, A is not equal, where AC is smaller. Therefore, one column for A should be inserted into this table. If A is uniform, then you don't need to include this column. Okay, P is due to real load, U is due to unit load. AB and BC equal to 0, 0, 0. Okay, AB due to external load equal to 0. Then delta T. In this case, delta T is only for AD. Only in AD. So only AD. If you have another members with delta T, or another members with increase in temperature, then you have to fill this column. In this case, only one. Okay. Maybe also there are some cases where all the members are subjected to temperature increase equal. Maybe, for example, this one is small structure. Small structure. During the fire. All members might be the same temperature. So 60, 60, 60, 60, 60. You can try. What happened? What happened to the deflection? Okay. If you convert this one into Excel, you can play around with the Excel, and you can play around what happened if you have 60 all, or what happened if you have 60 this member. You can try all. And this one is DLT, is the thermal expansion of each joint. Thermal expansion of each joint, but it's not the thermal expansion final. What I mean here is that 1.55 is the thermal expansion of 60, but this is not the final thermal of expansion. That one in another topic. That one maybe next year, not final. This one individual. Okay. Because why I'm saying that? Here. It is thermal expansion of a member, but not the final elongation or shortening of the member individually. This is what I mean here. Yeah. 1.55 is individually. Yeah. But when it is combined with another member, yeah, actually they are sharing, they are sharing, or they are tolerancing between each other, so that, yeah, maybe one member, yeah, even though it is 1.555, but because you share, yeah, you share with other member, maybe, yeah, it is only 1.3. Yeah, let's take that the example. Okay, now the sum of the work, yeah, internal work here. This is the sum of internal work. What is the sum of external work? No, there is no column. Yeah, the external work is here. This is external work. Yeah, because what is meant by external work is the work done by, yeah, the load, the virtual load, yeah, through delta deflection. Okay, so now you sum up the total 19.33. Yeah, 19.33. So what is delta? Yeah, so 1 multiplied by delta equal to 19.33. Therefore, delta equal to 19.33. Okay. Any questions so far? I don't know whether through online, yeah, it is easy to understand or not. Yeah, but I hope you can, at least basically, yeah, you know you have got the explanation, further explanation, yeah, to what you have read through the lecture note given to you. Yeah, I think you have, yeah, you buy the lecture note, is it? Yeah. But if you come to this lecture, yeah, without first, yeah, reading the lecture note, it's quite difficult. Yeah, so I hope, yeah, you have read the lecture note, and this one is as a further explanation. And if you, yeah, cannot understand, then you can, yeah, share your problem, yeah, in a group, or you can, personally WhatsApp to me, and I answer to all of you. Okay, I don't know how many slides, or maybe this is the last slide. Yes, last slide. Okay, summary. Uh, so the force in member, we have three. Yeah, three method. Yeah, and as I told you, I have another one method. Yeah, and we have also done virtual work method. Yeah, virtual work method for for displacement, and also, yeah, due to temperature, and also due to lack of heat. Yeah, and this is what we have done, yeah, so far in this topic. Okay, so if you have no question, yeah, I'll give you 5 minutes break, and I'll find some other example to show to you. Okay, 5 minutes. Yeah, because we have to utilize the time now. Yeah. Okay. Sorry, I couldn't find the additional example here. I'm not sure which file. So do you have any question now? Any questions so far? Okay, if you have no question, I go to the one that I showed you just now. Yeah. Okay. Here. Ah. Oh yes. Ah. Okay. Okay. One of you asked about this force, eh? Okay. Uh, I hope you can see you. Yeah. What is negative 9.43? Yeah. This one is equal to 0.667, yeah, multiplied by, yeah, sorry, yeah, multiplied by 3 square root, square root, or in this case multiplied by divided by tangent 45 degree. Yes, this is the formula. Okay, is it correct? Yeah, 0.667 divided by 1045. Correct or not?
Doctor,
No.
I divide still got 0.667.
It's not 1045. Sine 45. You got the answer, 0.943. Or 0.667 divided by 0.707. Or, yeah, or we can also do like this. Yeah, not enough. Okay, 0.667 multiplied by, yeah, multiplied the length of AB, yeah, the length of this member, slanting member. This slanting member, the length is equal to 3, yeah, time, yeah, 1.412, okay, okay, divided by 3. What is 3 here? Yeah. 3 is the distance, vertical distance. Why we take the vertical distance? Because 0.667 is vertical force. Okay, I don't have the calculator here. Yeah. 0.667, 0.667, okay, 0.667 multiplied by 3 multiplied by 1.412 divided by 3, 942. Yeah, okay. So, which mean by only one, yeah, by only here, by only one line of calculation, you can straight away calculate what is the force in this member. And why it is negative? Because it is compression. Okay, so what is this one? This one is equal to, yeah, 0.667 is equal to, okay, 0.943 multiplied by 3 divided by 3, okay, yes, equal to 0.667. Or actually what happened? Yeah, this force is equal to, yeah, the component or the rectangular component of this force. Rectangular component. So you can you can use the same method here. 0.4471 equal to 0.333 multiplied by 3 divided by 3, yeah, equal to 0.471. But the difference here is, yeah, compared to the resolution method, yeah, in resolution method you have error, so you know compression or tension. So in this case, you have to do quick, yeah, very quick determination whether it is compression or tension. Yeah, this one, yeah, why it is compression? Yeah, because the force here is to what? To counter, yeah, to counter this 0.333. So therefore, it must be in compression. It must be in this direction. Yeah, it must be in this direction. Yes. So, to me, this method, yeah, this method you must adopt this method. Yeah, you must adopt this method in your incoming years. Yeah. Okay. Any question? Are you more comfortable with this method or with the resolution method?
Doctor.
Yeah.
How did you get 0.667 from the 1 unit load?
Okay. 0.667, yeah. Okay, you can use you can use the moment or this one reaction here, or you can use this method, yeah. Check the reaction at the support. Okay, that's one thing. But in this case, okay, yeah. For this year, okay, yeah. But for next year, next year, uh, you don't have to use that formula. You don't have to use that formula because, yeah, in this case there is no horizontal force. Is it correct? Okay. In this case, there is no horizontal force. Oh, sorry. Hmm. In there is no horizontal force because this one is for unit load. Yeah? Okay, now for this unit load, there is no horizontal force. Okay, therefore, do you remember when you doing bending moment and shear force diagram? You use ratio, is it 1:3? So this one should be 2/3. Yeah, 2/3 because distance here is 2 or 2 parts. This one part. Yeah, this one should be 0.333. Yeah, or sorry, someone. Correct. So there are 3 part here. 3 part. So the reaction here is equal to 2/3. 2 part divided by 3 parts of 1, and the balance, the balance 1 minus 0.67 is 0.333. This is another thing that when at the time when you are doing bending moment and shear force diagram, okay, you remember, sometimes we don't have to, or we are not encouraged to write one by one. Yeah, what is RA, what is MA0? Yeah, in certain cases like this, it is very easy, straightforward. This is 1/3. This is 2/3. This is 1/3. Can you understand? Yeah, by ratio only, just by ratio. If this one, yeah, if this one is at the center, what is this one? What is the reaction? 0.5, 0.5. If this one is at the here, what is the reaction? The reaction is equal to 1, 2, 3, 4, 5, 5 divided by 6 multiplied by 1. 5/6 multiplied by 1 by ratio. Similar to this one, this one also by ratio. Sorry, the resolution method also by ratio. Okay. Is it clear? Okay. Any more question? Okay, I check the attendance again. Okay. Actually, can you look at my face now? I don't know how to check, yeah, my computer whether, yeah, my camera is on or not. Can you see me now? Can.
Yes, we can see
You
you.
can.
Okay.
Yes, sir.
Amirul Aiman. Hmm. Oh, sorry. Hmm. Amirul Aiman is not here. An-Nur Muhammad Ahnaf. An-Nur Muhammad Ahnaf. Okay. Sorry, yeah. I'm not very familiar with it. An-Nur. Oh, An-Nur, okay. Faris Matrazi. Faris ada Dua hari lepas Faris tak ada. Betul? Hari Isnin Faris tak ada ya? Dalam rekod saya. Hizwin tak ada. Hizwin. Okay. Kabinesh ada. Nur Safika.
Saya Nur Syafiqah.
Ada. Okey, terima kasih. Muhammad Faisal.
Faris ada tu?
Ya? Faris.
Ya.
Faris Mak Razi.
Ya.
Ada, okey. Saya dah catat ada. Kemudian Muhammad Ad-Din. Tak ada. Muhammad Faisal pun tak ada. Okey. Total participant. What is total participant? Forty-six. Total participant 46. Okay. 46 Muhammad Ad-Din tak ada, Muhammad Faisal tak ada. Okey. Apa nanti kalau ada kebetulan nanti sila message aja kat based on this list there are 46 but in my list here 1 2 3 4 absent. Okay, so this is the end of this topic. Yeah, as I said just now, yeah, I'll give you okay, I'll give you this slide, this one. And also this slide. Yeah, this one. Okay, by using resolution method and also by using this one. Yeah, this quick method. Okay. So any more question? I hope you can get something today, or you can get some understanding further. Yeah. About the tutorial, yeah, you have to do the tutorial as given in e-learning. Actually, I have not joined the e-learning yet because I just joined the university. And then about the tests, yeah, as mentioned by Dr. Yunus, as informed by Dr. Yunus, yeah, he will conduct the test maybe sometime next week after you have submit your tutorial. Yeah, and next week's we will go to another topic on deflection of beam and then column. Yeah. Okay, we have another 3 weeks. Yeah, before we end up this lecture for the final exam. Okay. So for that, thank you. Yeah, thanks for your attendance and thanks for your attention. Yeah. See you next Monday. Okay. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Thank you. Yeah.
Thank you, Doctor.
Yeah. Thank you.
Thank you, Doctor.
Thank you.
Thank you, Doctor. Thank you, Doctor.
Yeah.
Thank you, Doctor.
Thank you. Thank you. Yeah.
Thank you, Doctor.
Thank you.
Thank you,
Thank you,
Doctor.
Doctor.
Happy celebrating PKP. Yeah.
Home, stay
Yeah.
safe.
Stay safe. Stay at home.